week 4 practice assignment solution video. So let us start with question number 1. In question number 1, the probability density function of a continuous random variable x is shown in the figure, and the PDF is defined as e raised to the power minus x for x greater than equal to 0, and it is 0 for x less than 0. And we have to find the probability that x is greater than minus epsilon and less than 0. So this will be equal to integrate the PDF from minus epsilon to 0 with respect to x. But the PDF is 0 for x less than 0. So the required probability will be equal to 0. That is probability that x is greater than minus epsilon and less than 0. Now moving on question number 2. In question number 2, for a continuous random variable with defined PDF fx, we have to check which of these options are correct. So in option A and B, we are given that fx2 is equal to 2 times fx1. And we have to find whether the probability that x is greater than 2 minus epsilon and less than 2 plus epsilon, is it exactly equal to 2 times the probability that x is greater than 1 minus epsilon and less than 1 plus epsilon, or is it approximately equal to this probability? So the probability that x is greater than 2 minus epsilon and less than 2 plus epsilon. So as epsilon is very small number, so this is approximately equal to fx2. And similarly, the probability that x is greater than 1 minus epsilon and less than 1 plus epsilon, this is also approximately equal to fx1, as epsilon is a very small number. So from this, we can say that probability that x is greater than 2 minus epsilon and less than 2 plus epsilon is approximately equal to 2 times probability that x is greater than 1 minus epsilon and less than 1 plus epsilon. So therefore, option A is incorrect and B is correct. And for option C, we are said that probability that x is equal to x naught is equal to 0, and this is set for a continuous random variable. So this is true because for a continuous random variable, the probability at any instance is equal to 0. So option C is correct. And as the PDF of a continuous random variable is always continuous, that is, it is continuous in entire R, so option D is also correct. In question number 3, we are given a PDF for a continuous random variable, and we have to find the probability that x is less than equal to 4. So simply this will be equal to integrate the probability density function given with respect to x from minus infinity to 4, and the integration can be split into two parts as the defined PDF is piecewise. So this will be equal to integration of the given PDF with respect to x from minus infinity to 1 plus integration of given PDF from 1 to 4. And as for x less than 1, the PDF defined is equal to 0. So this will be equal to 0. So the probability is equal to integration of PDF with respect to x from 1 to 4. So this is equal to integration of 1 by 18 x square minus 8x plus 16 from 1 to 4 with respect to x. So this will be equal to 1 by 18 x cubed by 3 minus 8x square by 2 plus 16x, where the lower limit is 1 and the upper limit is 4. So this will be equal to 1 by 18 4 cubed by 3 minus 8 into 4 square by 2 plus 16 into 4 minus 1 by 18 1 by 3 minus 8 by 2 plus 16. So on further simplification, this will be equal to 1 by 18, and inside the bracket this will be 64 by 3 minus 64 plus 64. The second term will be minus 1 by 18, and inside the bracket we will have 1 by 3 minus 4 plus 16. This will be equal to 1 by 18 into 64 by 3 minus 1 by 18 into 37 by 3. So on further simplification, we can take 1 by 18 common from both the terms, and this will be 64 by 3 minus 37 by 3. And on further simplification, this is equal to 1 by 18 into 27 by 3, and this is equal to 1 by 18 into 9, which is 0.5, and this is the required answer. In question number 4, x is a random variable which is following normal distribution where mean is 10 and variance is 4. We have to find the probability that x is greater than equal to 8 given x is less than equal to 9. So this will be equal to, on using the definition of conditional, this will be probability that x is greater than equal to 8 intersection x is less than equal to 9 divided by probability that x is less than equal to 9. This will be equal to fx9 minus fx8 divided by fx9. So if we are subtracting fx8 from fx9, that is, if we are subtracting the probability that x is less than equal to 8, which is this area, from the probability that x is less than equal to 9, which is this area, we'll get the area between 8 and 9, which is this. So now let us separately find the required probabilities. So first of all, let's just find fx9, which is equal to probability that x is less than equal to 9. And as x is not standard normal, we have to standardize it. So this will be equal to probability x minus mu by standard deviation sigma. So this will become standard normal. So the standard normal is less than equal to 9 minus mu, and mu here in this case is 10 divided by standard deviation, which is 2. So this will be equal to probability that z is less than equal to minus 0.5. This is equal to 0.30854. And similarly, fx8, which is equal to probability that x is less than equal to 8. So we have to again standardize this x. So this will be probability x minus mu by standard deviation. So this becomes standard normal is less than equal to 8 minus 10 by 2. So this is equal to probability that z is less than equal to minus 2 by 2, which is minus 1. This will be equal to 0.15866. Substituting the values. So the probability that x is greater than equal to 8 given x is less than equal to 9, this will be equal to 0.30854 minus 0.15866 divided by 0.30854, and the final answer is 0.48. So this is the required answer for question number 4. Now let us move to question number 5. So in question number 5, we are given CDF of a random variable x, and the CDF is defined like this. And on the basis of this, we have to choose the correct options. So for option A and B, we have to check whether uh, x is continuous random variable or discrete random variable. So from the CDF, how can we determine if the random variable is discrete or continuous? So if the step sizes are 0, in that case the random variable is continuous, otherwise it is discrete. So let us find the step sizes. So how do we find step sizes? So for finding the step sizes, we look at the point where definition of CDF changes. For example, at x is equal to 0, in the interval x less than equal to 0, the CDF is equal to 0, and in the interval 0 to half, the CDF is defined uh, as 2x squared. So at x is equal to 0 in that interval, the probability is equal to 0. So in both the intervals, at the point where the definition changes, the probability is same. So this means here the step size is 0. Similarly, at all the points where definition changes, step size will be 0. So this random variable x is a continuous random variable, and that is also clear from the graph of CDF. So option A is correct and B is incorrect. And for option C and D, we have to find the PDF function of the random variable x from the given CDF. So to determine the PDF of random variable x from given CDF, we will simply differentiate the CDF with respect to x. So PDF of x is equal to differentiation of given CDF with respect to x, which is equal to in interval x less than equal to 0, as the defined CDF is 0, so the PDF will be differentiation of 0 with respect to x, which is equal to 0. And in interval from 0 to 0.5, the defined CDF is 2x squared. So the PDF will be differentiation of 2x squared with respect to x, which is equal to 4x. And similarly, in interval 0.5 to 1, the defined CDF is 1 by 2. So the PDF will be differentiation of 1 by 2 with respect to x, which is 0. In the interval 1 to 2, the defined CDF is x by 2. So the PDF will be differentiation of x by 2 with respect to x, which is equal to 1 by 2. And for the interval greater than equal to 2, that is x is greater than equal to 2, They defined CDF is 1. So the PDF will be differentiation of 1. So this will be equal to 0. So the PDF we get is 0 for x less than equal to 0, 4x for x greater than equal to 0 and less than equal to 0.5, 0 for x greater than equal to 0.5 and less than 1, 1 by 2 for x greater than equal to 1 and less than equal to 2, and finally for the interval x greater than equal to 2, the PDF is 0. So this is our required PDF of x. There is a typo in option C. This should be for the interval 1 to 2, this should be 1 by 2 instead of x by 2. So option C is correct and D is incorrect. And question number 6, we have to find the probability that x is greater than equal to 1 given x is less than equal to 1.5. So this will be equal to, on using the definition of conditional, this will be probability that x is greater than equal to 1 intersection x is less than equal to 1.5 divided by probability that x is less than equal to 1.5. So this is equal to probability that x is greater than equal to 1 and less than equal to 1.5 divided by probability that x is less than equal to 1.5. So for finding the probability that x is greater than equal to 1 and less than equal to 1.5, we will simply integrate the PDF which we have just calculated with respect to x from 1 to 1.5. And for finding the probability that x is less than equal to 1.5, we will simply integrate the PDF from minus infinity to 1.5 with respect to x. This will be equal to, as the PDF in the interval 1 to 2 is equal to 1 by 2, so the numerator will be integration of 1 by 2 with respect to x from 1 to 1.5, and in denominator, as the PDF is piecewise defined, so this will be equal to integration of 4x with respect to x from 0 to 1 by 2 plus integration of 0 with respect to x from 1 by 2 to 1 plus integration of 1 by 2 with respect to x from 1 to 1.5. And on integration, this will be equal to x by 2, where lower limit is 1 and upper limit is 1.5, and the denominator will be 4x square by 2, where lower limit is 0 and upper limit is 0.5, plus 0 plus x by 2, where lower limit is 0 and upper limit is 1 by 2. And on further simplification, this will be 0.5 divided by 2, and this whole divided by 0.5 plus 0 plus 0.25. And for the simplification, this is 0.25 divided by 0.75, which is equal to 1 by 3. And this is our required answer. In question number 7, The time taken by Rohit to complete a race follows an exponential distribution with expected time of completion of 10 minutes. What is the probability that Rohit takes less than 20 minutes but more than 10 minutes to complete the race? So let x be the random variable associated with number of minutes required to complete the race. So x is following exponential distribution, and it is given in the question that the expected time of completion is 10 minutes. So this implies that 1 by lambda, which is expected value of exponential distribution, is equal to 10. This implies that lambda is equal to 1 by 10. And now we have to find the probability that the time taken to complete the race is more than 10 minutes but less than equal to 20 minutes, which is equal to probability that x is less than equal to 20 minus probability that x is less than equal to 10, which is equal to fx20 minus fx10. And as we know, CDF of exponential distribution is 1 minus e raised to the power minus lambda x. This will be equal to 1 minus e raised to the power minus 20 by 10 minus 1 minus e raised to the power minus 10 by 10. So on simplification, this will be 1 minus e raised to the power minus 2 minus 1 plus e raised to the power minus 1. So this will be equal to e raised to the power minus 1 minus e raised to the power minus 2, which is equal to 0.232. Now moving on question number 8. In question number 8, we are given CDF of random variable x and we have to find the PDF. So for finding the PDF, we'll simply differentiate the given CDF function with respect to x. So this will be differentiation of 0 with respect to x for x less than 0, differentiation of x by ln 4 with respect to x for x greater than equal to 0 and less than equal to ln 2, and differentiation of 1 minus e raised to the power minus x with respect to x when x is greater than equal to ln 2 and less than infinity. So this is 0 for x less than 0, 1 by ln 4 for x greater than equal to 0 and less than equal to ln 2, and e raised to the power minus x for x greater than equal to ln 2 and less than infinity. So this is our required PDF of x. So option D is correct. Now coming on question number 9. In question number 9, we are given PDF of a random variable x and there is an unknown c in the PDF which we have to find. So if the PDF is valid, in that case the area under PDF will be equal to 1, that is integration of PDF from negative infinity to infinity will be equal to 1. So as the PDF is piecewise defined for different interval, this implies that integration of Cx from 0 to 1 with respect to x plus integration of C from 1 to 2 with respect to x plus integration of minus Cx plus 4c from 2 to 3 plus integration of 0 with respect to x from 3 to infinity. This will be equal to 1. For the simplification, this will be say x square by 2, where lower limit is 0 and upper is 1, plus c times x, and lower limit is 1, upper is 2, minus c times x square by 2, where lower limit is 2 and upper is 3, plus 4c times x, where lower limit is 2, upper is 1. This is equal to z, plus 0. This all is equal to 1. So on further simplification, this will be c by 2 plus c minus 5c by 2 plus 4c equal to 1. So on further simplification, we'll get c is equal to 1 by 3. So this is the required value of c. Now coming on question number 10. In question number 10, we have to find the PDF of the given PDF in the previous question. So for finding the PDF, so first of all, for interval x less than 0, the CDF will be 0 as the PDF for x less than 0 is equal to 0. And for interval where x is greater than equal to 0 and less than equal to 1, the CDF will be integration of the PDF from minus infinity to x, where x is between 0 to 1 with respect to x. So this will be equal to, as the PDF is piecewise defined for different intervals, so this will be equal to integration of 0 from minus infinity to 0 plus integration of x by 3 with respect to x from 0 to x. This will be equal to x square by 6. And now for interval where x is greater than equal to 1 and less than equal to 2, the CDF will be integration of fx from minus infinity to x with respect to x. So this will be equal to integration of 0 from minus infinity to 0 plus integration of x by 3 from 0 to 1 with respect to x plus integration of 1 by 3 with respect to x from 1 to x. And on simplification, this will be x minus 1 by 3 plus 6. For interval where x is greater than equal to 2 and less than equal to 3, the CDF will be equal to integration of the PDF from minus infinity to x, where x is between 2 and 3. So this will be equal to integration of 0 with respect to x from minus infinity to 0 plus integration of x by 3 from 0 to 1 with respect to x plus integration of 1 by 3 with respect to x from 1 to 2 plus integration of minus x by 3 plus 4 by 3 with respect to x from 2 to x. And on simplification, this will be equal to 4x by 3 minus x square by 6 minus 3 by 2. Then for x greater than equal to 3, the CDF will be equal to 1. And now finally, the CDF of x when x is less than equal to 0 is 0, and when x is greater than equal to 0 and less than equal to 1, the CDF is x square by 6, and when x is greater than equal to 1 less than equal to 2, the CDF is x minus 1 by 3 plus 1 by 6, and when x is greater than equal to 2 and less than equal to 3, the CDF is 4x by 3 minus x square by 6 minus 3 by 2. So this is the required CDF of x. Now coming on question number 11. In question number 11, let x1, x2 and x3 are the three independent observations from x. Find the probability that exactly one of the samples is larger than 2.5. So let us consider a scenario where x1 is greater than 2.5 and both x2 and x3 are less than equal to 2.5. In that case, the probability that x1 is greater than 2.5 and x2 is less than equal to 2.5 and x3 is less than equal to 2.5. So this will be equal to product of marginal as all the three random variables are independent. So this will be probability that x1 is greater than 2.5 into probability that x2 is less than equal to 2.5 into probability that x3 is less than equal to 2.5. And the probability that x1 is greater than 2.5, this can be written as 1 minus probability that x1 is less than equal to 2.5. So this will be 1 minus probability that x1 is less than equal to 2.5 into probability that x2 is less than equal to 2.5 into probability that x3 is less than equal to 2.5. So as all the three random variables are independent and they are observations from x, that means they are identical as well. So this will be equal to 1 minus probability that x1 is less than equal to 2.5 into square of the probability that x1 is less than equal to 2.5, as all the three random variables are from same observation x. So now let us separately find the probability that x1 is less than 2.5. So this will be equal to integration of PDF from minus infinity to 2.5, and as the PDF is piecewise defined, so this will be equal to integration of 0 with respect to x from minus infinity to 0 plus integration of x by 3 with respect to x from 0 to 1 plus integration of 1 by 3 with respect to x from 1 to 2 plus integration of minus x by 3 plus 4 by 3 with respect to x from 2 to 2.5. And this on simplification will be equal to 0.8. So the probability that x1 is greater than 2.5 and x2 is less than equal to 2.5 and x3 is less than equal to 2.5. This will be equal to 1 minus 0.8 into 0.8 into 0.8. So on simplification, this will be 0.2 into 0.8 into 0.8, and this is equal to 0.128. But we want to find the probability that exactly one of the random variable is greater than 2.5. So any one of the three random variables can be greater than 2.5 and the other two can be less than 2.5. So the required probability that at least one of the xi is greater than 2.5, this will be 3c1 into 0.128. 3c1 for choosing the random variable which will be greater than 2.5. So the answer will be 0.384. This is the required answer.